Hello, in this video we shall be discussing in details the various separation techniques. To begin with, decantation. Decantation is used to separate a mixture of liquids and denser solids. For example, sand and water. In this separation method, the solid is allowed to settle to the bottom and then the liquid is gently poured out, leaving the solid bar in the container. This process of pouring out the liquid out gently is called decantation. The next separation technique is sieving. Sieving is usually employed in the separation of solids based on their sizes. Example, separation of garri and rice based on the different sizes of their particles using a sieve. The sieve forms a mesh size that allows the smaller particles to go through, leaving behind the solids with larger particles. This separation technique is usually employed in pulp producing industries to separate out the starch content from the chaff. The next separation technique is evaporation to dryness. This is a method of separating salts that are heat stable from their solutions. Example of salt that can be separated out of this way is sodium chloride. So in this process, we evaporate the solution to dryness, taking off the water and leaving back the solid salt in the mixture. The next separation technique is distillation. Distillation employs the difference in boiling point to separate out two mixable liquids such as ethanol and water. For example, the boiling point of water is 100 degrees Celsius and the boiling point of ethanol is 78 degrees Celsius, although both of them are miscible. The next separation technique is fractional distillation. Fractional distillation is applied when two or more mixtures have closely related boiling points. Example is the separation of petroleum through what? Fractional distillation, because each constituent have boiling points that are close in value. The next separation technique is crystallization, which is used to separate out salts from their solution. But the peculiarity of these soluble salts is that they are thermolabile, meaning they are not stable to heat. So therefore, we heat gently and crystallize out the salt by either seeding it or scratching the base. Seeding involves the addition of the pure concentration of the salt to the solution to concentrate it, or by scratching the bottom of the separation medium to facilitate the crystallization of this salt while driving out the moisture. Another thing you need to note that when we separate salt via crystallization, these salts tend to have what we call water of crystallization, meaning sometimes water molecules are attached to the solutions or to the salts. The next separation technique is sublimation. Sublimation is actually a phenomenon where the movement of solid from solid phase directly into the gaseous phase without passing through the liquid state. Examples of solids that sublime include iodine, ammonium chloride, etc. So therefore, when these solids are in a mixture of others, they can actually be separated from a mixture of other solids by simply subliming them out of the mixture and obtaining them while they condense at a region of lower temperature at the top of your separation medium. The next separation technique is precipitation. Precipitation actually employs the difference in solubility of solids in two miscible liquids. Take for example, iron 2 tetraososulfate 6 is soluble in water but not soluble in ethanol, although water and ethanol are both miscible. Therefore, If I want to separate out iron 2 tetraoxosulfate 6 from a solution of water, I simply pour the mixture into ethanol and watch my iron 2 tetraoxosulfate 6 precipitate out in its insoluble form in a mixture with ethanol. This method employs the difference in solubility of solids in two different miscible liquids. And the next separation technique we're going to be looking at is chromatography. Chromatography usually employs the advantage of different rates of movement in a solvent over an absorbent solid medium. It is used to separate constituents of dyes, proteins, etc. And the next separation technique we are going to be looking at is the magnetic separation. Magnetic separation simply takes advantage of the attraction of substances to magnets and others that are not attracted to magnets. For example, ferrous metals such as iron, nickel, cobalt, and steel are actually attracted to magnets, whereas several other substances are not attracted. So for us to separate these materials that are attracted to magnets from others that are non-magnetic, we simply pass them through a magnetic field, and those that are magnetic are attracted to the magnetic phase. Therefore, those that are not attracted are left behind. So this method employs the difference in magnetic properties of substances to separate them out. And finally, in this video, we're going to be considering separating funnel. Separating funnel is a method of separating two immiscible liquids, that is, liquids that will not mix, giving rise to two distinct phases. For example, water and kerosene. If we mix water and kerosene, we'll get two distinct phases. So to separate out, it's possible to separate out the water and the kerosene by simply placing them in a separating funnel, a glassware material shaped in form of a funnel with a tap. So allow to settle in the separating funnel, and the liquids will separate into layers, and then you open the tap and get your denser solid, leaving back behind the less dense liquid medium in the solution. And this concludes the most common separation techniques you will come about. In the notes, you shall find other separation techniques also in your advisory. Quickly, let's look at criteria for purity. The criteria for purity are: 1. Definite melting and boiling point for pure substances. This entails that pure substances have a definite boiling and melting point. For example, the boiling point of water is 100 degrees Celsius, but impure substances have their boiling points over ranges. Example, between 99 to 105 for an impure water. And the last criteria for purity is that pure substances usually give one band of chromatogram after chromatography. In our next video, we shall be looking at how questions are usually faced from past trends in the last 5 years in the SSCE and the UTME examination, and we shall be answering them.